Now, we can also consider what happens if we reflect this ray over the y-axis. That would be some angle over here. And we need to figure out what is this yellow angle now, measured from the positive real axis. And since it's reflected, we know that this right here would be theta. So this yellow angle here, this would be pi radians or 180 degrees minus this angle theta. Since if we go all the way over here to the negative x-axis, that is 180 degrees or pi radians. And then if we take away theta, we get this angle right here. So we can say this angle is just pi minus theta, or we can do it in degrees, 180 minus theta, either way. And we can consider what the x and y values, or the sine and the cosine of this angle, are in relation to our normal functions in this first quadrant. So let's consider the cosine of this angle. This would be pi radians minus the angle, and the sine of pi minus that angle. And what we can notice is that the cosine value, the x value, is the opposite of the x value from the first quadrant. So this x value in the first quadrant, this is the cosine of the angle, but the cosine of pi minus that angle theta, this is now the opposite of this function here. So we can write that the cosine of pi radians minus the angle, this is equal to the opposite of the cosine of theta. And likewise for the sine function, we can say that the sine of pi minus theta, let me just make a little bit more room, is equal to the sine of theta. Since notice for the y value at this point, it is the same y value that we get from theta in the first quadrant. And since the y values at these 2 points are equal, we can say that the sine of pi minus theta is equal to the sine of theta. So we get 2 more of these reflection identities. We are now essentially just taking the opposite of the angle and then shifting it by pi. Notice that if we start with minus theta and then add pi to it, we end up at this yellow ray here. Now, the last thing we can do is we can take this ray here and reflect it across the x-axis, or we take this ray here and reflect it across the y-axis, but we get a ray that is down in quadrant 3 that would go to right about that point, and this angle would be the same size as this angle. It would be an angle of theta. And to find this angle here, this pink angle, we start with this value of theta and we add pi to it to get to this right here. Or another way to think about it is that we go pi radians or 180 degrees to get to the negative x-axis, and then another theta to get to this ray right here. So it's getting a bit messy, but this entire angle as measured from the positive x-axis to this ray right here, this would be an angle of pi plus theta, or theta plus pi. So we can consider its x and y value. The x value would just be the cosine of that angle, which is theta plus pi, or pi plus theta. And the y value is the sine of theta plus pi. And from here, we can compare it to our original trig functions in the first quadrant. And what we can notice is that the y value of this function is the opposite of the y value here. So we can say that the sine of the angle, this y value in the first quadrant, this is equal to the opposite of the y value down in this third quadrant, which is the sine of theta plus pi. And likewise, we can compare the x values. Notice that they are opposites as well. Since we are on the negative half of the coordinate plane. We're on the left side where the x values are negative, and over here the x values are positive. So it will be the opposite of that x value, which means that the cosine of theta, let me just make a bit more room here, is equal to the opposite of the x value from this ray. So it's the opposite of the cosine of theta plus pi. And we have all of these nice relationships now. We have the even and odd reflection identities and these other pairs of identities here, and these can be useful in different various situations.